Assalamu alaikum viewers, I am Farrukh Nadeem with a new Aspire tutorial. Today's tutorial is especially about tools. How to set up a tool in Aspire, any kind of tool. How to set up a tool in Aspire, whether it's any design, writing, or anything else you want to cut. How do you select the right tool for it? How do you choose the tool? How do we set the size? How do we set the feed rate? What should the spindle speed be? We're going to discuss all these things now. Here I have opened a frame. In this frame, as you can see, first of all, there's a border on the outer side. After the border, Surah Fatiha is written inside. Some words from Surah Fatiha are used as a title at the beginning. So now this entire design, this whole inscription, we have to. What will be the function of this? The wooden sheet we've placed on the outside. Look here, there's a cutting border, meaning a cutting edge has been made. This is where we'll cut the entire sheet to give it the final size. After that, these few lines here are being used as a border. Let me give you a suggestion here. When designing, always maintain the layers. It will make the work easier, the programming easier, and moving forward. After that, look here. There's another border placed, and then the first few letters of Surah Fatiha are used here as a title. After that, the rest of the surah is written here in full. The way we're arranging this is that first of all, we need to see that this area of the outer border will be made deeper, while this raised part will remain elevated. Then this line here, which is currently selected, we will engrave grooves here, referencing the border, and there will be a supporting border that we'll add here. After that, for all the surah that is written inside, we will use the V-Bit tool to design it. We will engrave grooves here, referencing the border, and there will be a supporting border that we will add here. After that, for all the surah that is written inside, we will use the V-Bit tool to design and cut it. The title words will also be made using the V-Bit, but since their widths are greater, how to adjust the V-Bit and what needs to be done, these are all the things we'll cover in today's topic. These will be covered today. Before we begin, one thing I definitely want to tell you, as I mentioned, the first step is to manage layers. To manage layers, I first select the outer border, right-click, and move it to a new layer. I named this new layer Cutting Border, and you can assign any color. Here, two things need setting. The new layer will remain visible. It's active, but we don't need it active now. You only make it active if you want to do further work on that layer. For now, we don't need to. We're just converting lines into a layer. See? I've converted it. After that, let's move to one side, and I'll zoom in. Look at this edge. By holding Shift, this edge, this one, and this one, I have selected 4 geometries, 4 lines. So as you can see, throughout all of them, the entire border has been selected. The design has already been done, and the lines have been properly spaced. Since you've already learned about design in earlier lectures, I don't want to spend more time on this now. So right-click on the border, move to Layer, New Layer. If you already have layers created, you can move it to one of those. Otherwise, create a new layer. Here, I'll name it, we can call it Border. From here, I'll set its color to red. And where will I use this border? I want the depth of this border to be 4 millimeters. Border depth, 4. I want the depth of this border to be 4 millimeters. I set the border depth to 4, and then I clicked OK. As soon as I click outside, you can see it has been converted. Now, after this, let's come here. This line that's drawn here, I want to use the same cutter that we'll use inside to make this line as well. So look, there are 2 ways to do this. One way is to take it. One way is to make a double line and run the inner groove on it. Another way, to save time, is to just run the tool directly over this line. You can run it exactly on top, on the inside, or on the outside. It's up to you, whatever you prefer. So after selecting this line, I right-click and move it to a new layer called Helping Border. You can make it as deep as you want, 4 or 2, however deep you want it. I said Helping Border, so let's say 4, meaning we'll set it to 4 millimeters deep. Here I select this color and click, and you can see the line has been applied here. Next, on the inside for Surah Fatiha, look here, I selected this much area. Pay close attention to my selection. When I selected it, Rabb al-Alamin, the noon in Alamin, its zabar and the dot of the noon, I didn't include them completely in the circle so that they wouldn't get selected along with it. I made the selection, and as you can see, the rest of the verse got selected. I'll right-click and move it to a new layer for Surah Fatiha, and I'm changing its color. From here, I gave it this lime color. Click OK, and you can see it's appeared here. Now after this, when I select like this, these words also get included in the selection. So here I turn off the Surah Fatiha layer. Now I'll select this here. After selecting it, you can turn it back on if you want and then select it. You need to select this area. See, when I select like this, these words also get included. So here I turn off the Surah Fatiha layer. Now I'll select this here. After selecting it, even if you turn it back on, it won't be included in the selection. And now I'll move this to a new layer, the Surah title. Alright, if you want to add a reference for the tool along with this, you can write it. There's no problem. I'm not writing it here. And here I've selected this color. Click OK. So in this way, the layers are managed. Save the file as well. After that, now we're moving on to its tooling. So look, as soon as I switch here to the Tool Path command, one thing you should keep in mind before this is that the file you've selected or the one you've created to finish it completely and precisely. So this particular section, and this is indeed the narrowest area of the entire design, which measures just 1 tiny millimeter. Now look closely, I'm about to tell you something incredibly important and absolutely crucial for your understanding. Whenever you meticulously design any object or component, you truly need to always keep in mind that there should be at least a sufficient and adequate amount of area for the manufacturing tool to comfortably pass through without any obstruction. Usually when we're in the process of designing, we often don't pay sufficient attention to these critical details at all. I'm carefully selecting the specific border and am now going to apply the offset function. Here, I set it to 3, watch this, and delete original. And on the outer side, I moved it 3 millimeters out, offsetting it. I selected it like this, did an inside offset, and deleted the original. Now look, what happened is that there's space left on the sides, and I'll have to select both lines again and move them. Now I already have a layer with border depth 4. I moved it into that layer, and this way we got a bit more space. Now, why did I do this? You'll understand this as we go further. One thing is clear, we need at least a 3 or 4 millimeter cutter here, or a 1/8 cutter, to clear this area. After that, if we go further, what do we need to do? As soon as I activate the toolpath at this spot, watch this. I said that we need to clear out these areas, so for that, we have the pocket toolpath available here. As soon as we go to the pocket toolpath, the first thing to do is set its depth. Let's set it to 4 millimeters. After that, select the tool. You can see that a 4 millimeter tool is already selected here. This is an end mill. Make sure you're in the metric system and select the 4 millimeter tool. Now about this pass depth, since it's customizable, we've set it up according to our own preferences. But the standard recommendation is to set it to half the tool's diameter. Now, when it comes to wood, it's often said that you should set the pass depth to at least equal to the tool's diameter. Here, our local practice depends on a few things: what material you have, which tool you're using, and what kind of machine you have. That's your own practice, and you can even go deeper if you want. But in any case, the best practice is an end mill is a type of cutter. What are feed rate and plunge rate, and how do we set these? Look, I'll say this again and again. Everyone has their own practice, their own way of doing things. The reason is that the tool machine, meaning the bit, and sometimes I refer to the bit as the tool, so pardon me for that. I'm using an end mill, a type of cutter. How are feed and plunge rates set? Everyone has their own methods, influenced by the bit and machine. Tool information, like feed, depends on these two factors. So I'm giving you some general values here, but you can set them as you like. Now look, here I've set the RPM to 18,000. If your machine supports 18,000, then use that. Otherwise, go down to 16,000. You should keep the RPM between 12 and 18,000. After that, there are two things here: feed rate and plunge rate. The feed rate is how fast your machine travels during cutting. For softwood, the feed rate we use, see, there are 3 or 4 options we have. Usually the standard you'll find, if you look it up online, is in inches per second, and then everyone has their own practice. Some use one, some use another. Now, most people just look at this value here and don't pay attention to what unit is actually set. So when you're setting the unit, make sure to check that. Generally, the feed rate we use for softwood, for that, the value is usually set between 3.5 to about 4 3/4. Look, if I'm using inches per second, I'll set the value here to 4. Now, if I change this to inches per minute, you can figure it out yourself. If it's 4 inches per second, then multiply 4 by 60, and you get 240 inches per minute, automatically. It will automatically update values if set to meters per minute. See, it now shows millimeters per second, millimeters per minute, meters per minute, and inches per second. I'm explaining this using inches per second as the base unit, but you can adjust it as you like. You can switch from inches per second. Similarly, if you set it to meters per minute, it will automatically update its values. See, it now shows millimeters per second, millimeters per minute, meters per minute, and inches per second. So I'm explaining this to you using inches per second as the basic unit, but you can adjust it however you want. You can set it up in inches per second and choose whichever unit you prefer for your settings. It will be set accordingly. Usually the plunge rate is kept at 1/4 of the feed rate. So if I'm setting the feed rate to 4 here, that means I can set the plunge rate to 1. Now, what is the plunge rate? When the tool is plunging into the material, the speed at which it does so is measured in inches per second. It's better to keep this value low, but as I mentioned, usually our video. We keep the feed rate at 1/4, and here you have to assign the tool number. It's vital to assign this tool number. After entering these values, I apply and click OK. Clicking OK shows the working preview in the window. We'll discuss this later. Clear pocket. It means in which form do you want to do this, an offset or a raster. In raster, it'll go in a zigzag pattern. In offset, it'll move around the edges. Then there's the pocket allowance. If you want to leave a little edge on the sides, that's set here. This is the ramp plunge move, meaning when the cutter enters the material, it shouldn't go straight down, but rather enter from the side in a taper form. These are some of the options. For now, I'll leave it here. So, for the purpose I want to get the work done, which one is it? Look, now we have to set the border depth to 4. I'll click here on border depth 4, and then we'll bring it here. Here, we need to select close vector, because the work isn't being done on open vectors, it's being done on close vectors. As soon as I select border depth 4, it automatically, since all the objects are closed and connected to each other. So it will come here, and you can close it. After closing, you can also set it to border 4 here. So calculate it, and look. After calculating, the design appears in front of you. And see, now the single cutter has passed through here once. Look, it hasn't passed through here. It hasn't passed. Now let's go to the preview so we can see the design more clearly. Look here, these lines are connected, right? We check the distance from here, but from this side, it hasn't passed. Now let's go to the preview so we can see the design more clearly. Look here, these lines are connected, right? We checked the distance from here, but we didn't check from this side. So these lines didn't give enough clearance. They didn't give the cutter a chance to pass through. So what will we do? Double click on this. Here, I'll just change the end mill. I'll set it to a 3mm end mill. Now, if I use a 3mm one, if I want to do it in a single pass, I'll set it to 4 here, so it completes in one go. From here, just like I told you before, set its value accordingly. For example, if I set it to inches per second, now since the cutter's diameter is a bit smaller, you can keep it a little lower here. I'll set it to 4.25 here. So look at this. Set it to 4.25, or just keep it at 4. I'll keep it a bit slow. 0.8 is fine too. Apply that. Let's increase its speed a bit. I'll take it to 16,000 RPM. After applying, I clicked OK. Now see, it's done. Calculate, reset the preview, preview all, and now look, the cutting is happening per hour, which The thing we wanted to observe or do here, it has performed that. Now, how can we reduce this time even further? Because the tool will keep running so finely inside over and over. So how do we avoid that? Let me go back to the programming. Look, here we set the tool to 3 millimeters. Now here we have an option, Use Large Area Clearance Tool. Turn this on so that for the larger areas, which here, moving forward, I'm selecting and assigning a 6 millimeter tool. I've set the tool to 6 millimeters. In past steps, I set the step over to 40%. Here, I set the RPM to 14,000. When you come here with inches, you'll see that since the tool is bigger, we still have to adjust the feed rate a little. So here, I am adjusting its feed. I keep it at 4 here and set it to 0.8, apply it, and click OK. Now look, we've used two tools in one program. One is 3 millimeters and the other is 6 millimeters. So as soon as you calculate after doing this process, everything else remains as it is. Now look, the toolpaths are done here. When I reset and view it, you can see the work is the same as what we did before, but so what exactly is the fundamental difference we are observing here? The more expansive and considerably larger areas, specifically those open and unobstructed spaces within this particular context, will be comprehensively managed and effectively handled by the significantly bigger and more robust entities or mechanisms that are specifically designed for such extensive operations. This is the toolpath summary. Look, it created separate programs for this and that. The difference, larger open areas cut with the bigger tool, smaller areas with the smaller tool for better quality. Overall, the total estimated time is now 14 minutes, whereas before it was at 11 minutes. You're seeing this correctly. This difference has come up here. Why did this difference occur? Because the tool was changed, right? Now there will be a slight difference between the speed of the bigger tool and the other one. But the most important thing to notice here is that the tool was set according to your requirement. Instead of clearing everything with a 3 millimeter tool over and over, now a bigger tool was used, and it did the same job faster, so you got it done quickly. Look, if it cleared this area in 5 minutes, and the finer area took 8 minutes, or actually 9 minutes. Now, if I go into its experiment, let's come here. If I come back to this again, here we had used a 3 millimeter tool, and from above we used a 6 millimeter one. Now, instead of 6, if I have it change the tool and bring it to 5 millimeters here, let's calculate it. After recalculating, I reset the preview, previewed all, and now let's look at the time summary here. So now, see, the total time has come down to 9 minutes. Now, what happened here is that the tool got smaller than before. First, we used a 3 millimeter tool, so it took 11 minutes. Then when we used a 6 millimeter tool along with the 3 millimeter, it went up to 13 or 14 minutes. When we used a 3 millimeter tool and a 5 millimeter tool, the time came down to 9 minutes. What's the reason for this? It's very simple. Try to understand. The bigger the tool you use, the less work the smaller tool has to do. Now, the smaller the tool you use, if you use a slightly bigger tool, like I went from 3 to 5 millimeters, or earlier from 3 to 6, you'll see this difference. Why does this difference occur? Let's zoom in on an area. When the tool enters this pocket for cutting, from the outside it has 3. So using a slightly bigger tool, like I went from 3 to 5 millimeters, or earlier from 3 to 6, this is the difference you'll see. Why does this difference happen? Let's zoom in on an area. When the tool comes into this pocket for cutting, you can see that with the 3 millimeter tool, it has done this cutting from the outside, and then after cutting with the 3 millimeter tool, it cut this area twice, whereas on this side the cutter passed once, here and here. These are the cuts made at 5 millimeter intervals. Now, if I had set the interval to 6 millimeters here, then on this side there would have been only one cut, and the rest would have had to be cleared with the 3 millimeter tool. Let's practice this a bit more. If I double click here and set this 5 millimeter tool to cut at 8, usually people think, hey, just use an even bigger one. See, now it took it back to 12, then went to 13 minutes. The reason for this is that, as you can see, on this side it's only making 1 or 2 cuts. See, now it took it back to 12, then went to 13 minutes. The reason for this is that now, look, on this side it only had to make 1 or 2 cuts, but for the rest it has to use the small tool. Here you can see the workload for the small tool has increased. That means when you use a bigger tool, the small pockets that are created require more work from the smaller tool. See, now the small tool is working here, 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 and here as well. Choose tools carefully. Oversized ones burden smaller tools. Designed to minimize closed pockets, using larger tools where possible. For numerous closed pockets, match tools appropriately. I'll adjust this to 5. Here, I'll also reset, preview, and preview all just to take a look, though it's not really necessary, just for the sake of checking. After that, come here and recopulate it. See, it's back to 9 minutes, and this way our file is ready. So up to this point, our first toolpath is complete. I'll view the tool now. After this, what we need to do is, on the inside, we've created a help groove. Now, how exactly do you intend to create this particular groove? Are you considering performing this operation using the metric system, specifically in precise millimeters, or would you prefer to utilize the imperial system, working with accurate inches? The ultimate decision rests entirely with you, the user, based on your project's requirements and personal preference. Here, observe closely. It conveniently provides the essential tool necessary for this task. ROS, a highly reliable and efficient instrument designed to assist you in achieving the perfect groove with ease and precision. So let's add a new cutter here. I did this. Here you'll select the end mill, and I've entered 5 millimeters here. I set its passed up to 4, set it to 40%, set it to 14,000 RPM, and set inches per second to 4. All these values are now okay. I've selected it with the 5 millimeter. This 5 millimeter cutter is now applied here, and I want to keep it out. Zoo hell-known functions are the Eister Heuberg photography, it's there, Rosewell, Housemite. And along with that, I'm also writing 5 millimeters end mill 5, so that I have a reference saved. Calculate this. As soon as I calculate it, look, it's done. Reset, preview, and preview all to check. First the outer one, then it has given a border on the inside. See, it's done, okay? This border has appeared. Close it. Up to this point, keep saving the file as you go. Switch to 2D view. Now see, our work up to here is done. Now on the third one, that is, we did this in the first process. Now in this one, look, 2 tools are being used for clearing. A 5 millimeter one. You can also rename it from here. I wrote border end mill 5 millimeter. Let's rename the border to end mill 3 millimeter so that we can effectively keep a precise track of all the various tools as well. So when we proceed to install these essential tools, we will also ensure that this particular work is thoroughly and completely done. Next, we absolutely have to meticulously work on the Surifatia that is clearly written here, and we have to carefully make it with a specialized V-bit. And for the specific V-bit, please observe here, we currently have this exact V-bit readily available. The most important thing is to select its tool. As soon as we go to the V-bit in the tool section, we see that only 3 V-bits are available here. If I switch to the metric system, there are also just 3 here. So I'll create a new tool here. I selected the V-bit, and after selecting the V-bit, I'll set its diameter to 25 millimeters. And here, I'll set the degree to 120. Now, why am I increasing the degree? See, the higher the degree you set, the shallower its depth will be. The lower the degree, the deeper it will cut. The reason is that the depth is determined according to the degree of the bit. That's why I'll use a 120 degree cutter. This is commonly available in the market. There's nothing special about it. If you want a 120, if you find one, no problem. You can also use a 50 millimeter diameter cutter. It won't make a difference. Your design will keep it bounded. After that, here the final pass step over is coming in at 2.1%. For now, just keep all these settings as they are. Now look, here's that same point again. If I switch to inches per second, the value that comes up is the feed rate. For plunge rate, I'll set it to 1, apply. Ideally, it should be 0.75. Even for the fourth one, set it to 0.75 and apply. Regarding tool number, since nothing's specified, all run is tool 1. You need to change it. Normally, this would be the third tool if there's an ATC. Here too, it'd be the third tool, as our first tool is 3 millimeters. Exit, select vector, uncheck, reselect Surah Fatiha, confirm. Okay, name V-Carve Surah Fatiha, set V-Carve 25. 120 degrees, calculate. Click calculate.